Hi friends, my name is Apparao, working as Associate Professor in Computer Science and Engineering Department at Marri Laxman Institute of Technology and Management, Dundigal, Hyderabad, Telangana State. Today, I want to discuss about protocols on the transport layer in advanced computer networks. So in this session, I want to cover protocols on the transport layer. So for this advanced computer networks, I covered course objectives, course outcomes of the ACN, and the textbooks I have referred, that is computer networking and computer networks and internets, a practical guide to advanced networking and computer networks as a reference. And in this video lecture, I have taken the content tutorialspoint.com as well as geeksforgeeks.org. So now see, in this module, just I want to cover transport layer reliable communication protocols on. In module 2, I want to discuss about protocols on the transport layer reliable communication. I'll discuss. So now, see, if you want my previous lecture about peer-to-peer application communication, you can check in my previous session. Now see, protocols on the network layer, the basic information about protocols on the transport layer. The transport layer is the fourth layer in the OSI model, as we know that, and the second layer in the TCP/IP model, as we know that. The transport layer provides the end-to-end communication between source and destination and reliable delivery for the services. Suppose, for example, see, if you want to share the information in between two devices, that is source and destination, so we need a reliable communication media, that is wire or wireless. We are discussing about wireless, right? So now for that, so we have a different types of layers. In that we choose a transport layer on this session. Now, so this transport layer provides end-to-end communication. Suppose, for example, if you want to send some XYZ data from source and it must be received from the destination side, right? So now for this end-to-end communication between the source and destination and reliable delivery is in the services. Therefore, transport layer is known as the end-to-end layer. The transport layer takes the service from its upward layer, which is application layer. So obviously transport layer and application layer. So this is upward direction in OSI model. The application layer and provides it to the network layer. Segment is the unit of data encapsulation at the transport layer. The main intention of this transport layer is unit of data encapsulation. So now this is the simple pictorial representation of the transport. So now transport layer, I discussed TCP and UDP. So these are the major protocols available in transport layer. Then after I will discuss about application layer protocols. So now the main functionalities or functions of the transport layer. The first one is the process to process delivery and end-to-end connection between devices, multiplexing and demultiplexing, data integrity and error correction is all, conjunction control and flow control. So these are the main functions of the transport layer. Now characteristics of transport layer is that the two protocols that make up the transport layer are TCP and UDP. So these are the main protocols, especially in the transport layer. We'll discuss TCP as well as UDP in this session. The datagram is sent by the IP protocol at the network layer from source to host to a destination host. These days, nowadays, an operating system can support environments with multiple users and process, right? A program under execution is referred to as a process. Suppose, for example, see, if you want to run a OS, especially in different devices, obviously we need a process, right? Without process, there is no communication, especially in the operating system. That's the reason I given the statement like this. Operating system can support environments with multiple users and process. A program under execution is referred to as a process. A source process is transmitting a process to destination. Process when a host sends a message to another host, certain. Connections to connection ports referred to as the protocol ports. So obviously source, destination, communication media, who is going to send this information? Obviously there must be a one protocol. Protocol is a set of rules given by the governance. So now host sends a message to another host. So obviously host to process and end-to-end communication, these are the major words, especially in transportation the network layer. as well as transport layer. So are defined by the transport layer protocols. A positive integer address consists of 16 bits define each port. So obviously let's consider have an example. So let's consider switch. So in this switch there are a number of ports based on the device availability of the device switch. So now transport layer I want to discuss now. The transport layer is represented majorly by TCP and UTP protocols, as I said discussed today. Almost all operating systems support multi-processing, multi-user environments. This transport layer protocol provides a connections to the individual ports. These ports also known as the protocol ports. Transport layer protocol works above the IP protocol and delivers the data packets from IP source to destination port and from the originating port to destination IP services. So now see these protocols I want to discuss about. First one is UDP, then after I'll discuss about TCP. UDP stands for User Datagram Protocol. As we know that User Datagram Protocol provides a non-sequential transmission of data. So it is a connectionless transport protocols. So simple, so as per our example, suppose source to destination. So if we send a data or else exchange a data from source to destination, so there must be a one connection, right? So if we send a message, obviously there must be a acknowledge must send to the destination. So but this is a connectionless transport protocol. UDP is a connectionless protocol. So why? Because there is no specific acknowledgement, and if you miss this any packets, so there is no recovery mechanism. UDP protocol is used in applications where the speed and size of the transmitted is considered as more important than the security and reliability. Now user datagram is defined as a packet produced by user datagram protocol. UDP protocol adds checksum error control, transport level addresses and information of the length to the data received from the layer above it. Services provided by the user datagram protocol are connectionless services. So faster delivery of messages, checksum and process to process communication. So if it is a UDP, so these are the facilities available in especially UDP. First one is connectionless services, faster delivery messages, checksum and process to process communication. So now by seeing this example you get the good idea. So now broadcast one to all, multicast one to several. So now this is a client, this is a server, age old story as we know that. Suppose for example if we send the message, so obviously server gives the response, request, response and request. So this is called UDP. So now UDP segment, that is user datagram protocol. So while the TCP header can range from 20 to 60 bytes, the UDP header is a fixed basic 8 bytes. So suppose for example, so if there any message or else data exchanging processes, there must be a one address for the data. So that address is included some fixed point. So all required header information is contained in the first 8 bytes with the data making up the remaining portion. Because UDP port number fields are 16 bits long, the range of possible port numbers is defined as a 0 to 65535, that is 65,535. So with port 0 being served. So now see, this is the header. So if it is a UDP, so this is the architecture texture of the UDP. UDP header we have UDP data, next source port 2, next destination port 2. So apart from this, checksum is 16 bits, length 16 bits. It's maintained like this. So here, so we have a data. So if we want to send a data, obviously we need a header. So obviously we have to provide the source port as well as destination port. So there must be a length also for this UDP, and checksum is also available. So this is the entire 8 bytes UDP header. Now source port. So this is I want to discuss source port. Now source port is 2 bytes long. Field used identify the port number of the source. Suppose, so which port you are going to use for sending the data or else exchanging the data. So that provides a source port. So as well as destination port, it is also 2 bytes element used to specify the packet's destination port. Next one is length. So how much length is available, especially in UDP? The whole length of a UDP packet, including the data and header, the field has 16 bits. Now see, so this is 16 bits, source as well as destination. So checksum, this is bit different. The checksum field is 2 bytes long. This is 2 bytes long. Now the data is added with 0 octants at the end. So to create a multiple of 2 octs, it is the 16 bits one's complement of one's complement sum of the UDP header. So the pseudo header contains information from the IP header and the data. So now advantages and disadvantages of UDP. UDPs also provide multicast and broadcast transmission of the data. UDP protocol is preferred more for small transmissions such as DNS lookup. It is a connectionless protocol, therefore there is no compilation to have connection oriented network. UDP provides fast delivery of the message compared to other protocols. Now disadvantages of UDP. In UDP protocol, there is no guarantee that the packet is delivered. UDP protocol suffers from worse packet loss. UDP protocol has no conjunction control mechanism. UDP protocol does not provide the sequential transmission of the data. Thank you for watching this video.